Okay, welcome on this video on 2014 on the ellipse and parabola. So we have the cat here. Alright, so you can see what I was doing first was sketching the approach at it. So I'm just going to start here. So the curve ABC is a parabola with a vertex at B. So the curve ABC is a parabola with a vertex at B. Right, so I'd start with drawing the parabola. Kind of the first paragraph to explain it's generally where to start first. Alright, then the curves DEF are identical portions of the same parabola. So that's translation. So you move the original parabola across, and then the curve JKLM is an ellipse. Right. Okay, I'm just going to sketch out my approach to the parabola. So I have the base of my parabola. Yeah, I'm going to use the rectangle method to draw in the parabola. Now, I can't think of any number off the top of my head that divides 70 evenly and 110 evenly. So I'm going to divide each side into 4 divisions, we'll say. So I'm going to draw a line at any acute angle, mark 4 equal divisions along that line. So we'll say every 20, 2, 3, 4, and then I join this one back to the corner. All the lines then are parallel using your set square and t-square. Okay, I'm going to do the same down here, draw a line at any acute angle. Okay, I'm going to mark 4 equal divisions along it. And then all the lines are drawn back at any acute angle, and then I'm going to go up and join these to the vertex B. So where the first one touches the first one, second one touches the second one, third one touches the third one, and then we can mirror these points across by putting our compass in the middle and swinging them over. Right. So we get started at that. So the base of the parabola is 140 wide, so the distance from letter A on your sheet to letter C is 140. The midpoint is 70. Parabola is 110 high. So 110 high. Now I'm just going to pause there for a second. Okay. There's our center line. Now, as I said, we're going to divide this line up into 4 equal divisions. So we're going to draw a line at any acute angle, and the length is irrelevant as long as there's 4 equal. It can be divided equally by 4. So I made it 80. I'm going to mark every 20. Now I'm going to join the last point here to the top corner of the rectangle, and I'm going to put my t-square underneath it. So my t-square is not tight against the left hand side of the desk, it just sits under the set square and it's held firmly. I'm going to draw the lines back, and then I'm going to join these then to the vertex. Okay, now I'm going to divide the bottom up into 4 equal parts. So I'm going to draw a line at any acute angle. Okay, I'm going to make it 8 again. I'm going to mark every 2. And then, so we join the last one here to the corner. And put my t-square underneath the set square. Hold it tight, don't let it move. Slide the set square on. Now, I'll freehand sketch those curves in. Now I'm going to do the second 2 parabolas. Now, this is, I'm going to do parabola number 2 and 3. So the curves DEF and GHF are identical parabolas, portions of the same parabolas with the vertices at E to H. So eventually, really, this parabola moves here. The vertex from B moves to E. Okay, so I'm going to bring all these points across. And I'm going to take the distance with my compass, the distance between B and E, because all the points move the same distance, and you mark it in along the lines. So you mark it in for A as well, and then on this side, and from C, from this one here, and you freehand sketch them in nice and lightly, okay, before you heavy in later. So I'm going to do that one now. So I find point E. So from C, E is over 40, 45. So I'm going to mark over 45. So I'll go straight up. So the height is the same as B. So that's B, A, C, and E. Now we're going to take our compass and we're going to set it to the distance between B and E. Set the distance between B and E. And we're just going to bring these lines across. Now, from each of the points now on the parabola, look, there's points on the new moved parabola, D, E, F. And then we're going to freehand sketch these points in. So we're going to freehand sketch them in. Freehand sketch them in, I'll heavy them in later. To get the parabola GHF right, what I could do then, is find point H, and then all the lines could be moved then, or all the points could be done like this. So you take the distance here, and you step it along those lines. You could do that, it's quick, it's not the most accurate way. So what we'll do is we'll join B to H, join B to H, draw all your points, or all the lines from each of the points in the first parabola, parallel to F to H, and you take the distance between B and E, and you mark it then on each of the, not the distance between B and E, the distance between B and H. Alright, so you take the distance between B and H, and you mark it then on all your purple lines there, so you can see, and that gets the inside parabola. So I'm going to do that now. So to find H, measure in 10 from the center here, go down at 45 degrees from E, so that's point H. Now I'm going to join B to H. So I've joined B to H. Sorry, get my other set square. So B to H, then I'm going to slide the set square down to all the points in the first one, draw light lines. Now, set your compass to the distance between B and H, and look, you mark it then on the lines there between B. You set your compass to the distance between B and H and mark it on your sloped lines. I think I missed one there. I did this one. Then you can freehand sketch the curve in. There you go, that's all you need there. That circle down here at A and C is radius 25. So radius 25 circle. A and C, and then we have the ellipse to do for the cat's head. Okay, right, so to get started on the what's called ellipse, so the minor axis here is at 60 degrees and it runs from the vertex to the semicircle. Okay, the center line okay, or the major axis, okay, is 50 millimeters up from point M, and to get point M, you go down 20 and across, horizontally across, until it intersects that inclined minor axis at 60 degrees. Now, we have the curve JLM is an ellipse with focal points at N and P. So we have the focal points N and P, and we have the minor diameter. We're missing the major. So, the major diameter. And you can't see that, I'll move that. So now, what we do know is that what we studied in class is F1, so the N is the equivalent of F1, P is the equivalent to F2. F1 to any point on the curve back to F2 is equal to the major diameter. So F1 here to this point in the curve plus this line here, those two purple lines there are equal to the major diameter. So if we have the focal points here, alright, and we have the minor, alright, we can add these two lines together. So I can add line 1 and 2 together and I have the major diameter, or even quicker and faster, I can just take the distance from M to P and swing from the centre, and that's your major diameter. And then we're going to divide up into 60, 30, so where the division line hits the major circle parallel to the minor axis towards the major, where the division line hits the minor circle parallel to the major axis away from the minor axis, so where it hits the minor circle parallel to the major axis away from the minor axis until they intersect. So we'll get cracking with that. So point M is down 20 from B, horizontal line across there, 60 degree line through what you call it, the vertex of the semicircle. So that's the bottom of the minor circle there, that's the bottom of the minor circle. Oh, sorry, I shouldn't have heavy that portion of the parabola in here, that's sloppy in there. Get rid of that soon. So there, this is the centre point of the ellipse. The major axis is perpendicular to that. Now, the focal points N, 25 and 37 is equal to 62. Okay. So 62 to the left and right. That's N, that's P. Here's our minor circle here. Now, as I said, to find the major, look, we're going to take the distance from M to N. So this is half the major diameter, and we're going to bring it to the centre, and we're going to swing the major circle, and then we're going to divide it up as I spoke about it. So where the division lines hit the major circle parallel to the minor axis towards the major axis. So a freehand sketch. Then the remaining bits, right, okay, so the eyes, 25 left and right, centre and up 20. Then the tips of the ears, so up 64 from the major axis and in line with the focals. And then they're joined to the opposite circle then. You have to show the construction line. Okay, you have to show the construction line, the light line going from the centre through the curve. Right, then the nose, okay, semicircle there, and nice isosceles triangle in there. So you bring down those vertices until they hit the major axis. Okay, looks like one of mine is going to be a little bit off now. No. So here's the nose. So it's a nice isosceles triangle. But you have to have those light lines coming down from the vertices of the circles. Now, the mouth. Okay, so center point is there at the triangle, and it's there. 25 and 22 is 57. Or sorry, not 57, 47. 25. So 25 and 22 is 47. Get your compass here. So that's there. Radius 47. And you're doing it from both ends of the triangle. And then the whiskers, right. So we have our angles here, 24, 6 and 6, and they're all originating from here. So I'm going to get me a protractor, and I'm going to show it to you on the next sheet below. No, I don't have any more sheets left. Right, so I'm going to put my protractor here. I'm going to mark my 24 degrees, and then my every 6 degrees. I'm going to draw my lines through there, and then you start to become heavy. They start heavy from where the lines are originating or radiating out from that point there. Hit this line going through the circle, the centre line of the circle, and you swing an arc 80 to figure out what length. So this is where it starts. So 24, 30. And then careful not to mark 26, which I actually done there, getting confused there, wouldn't point on the ellipse. So just set that again. So four, 6. So set your compass to radius 80. Swing your arc. You can heavy in. Same on the other side now. So 24, 30, 36. radius 80. So I'll heavy that in now.